Recently in math, we have been working on problems such as if this was the whole and we divided this into fourths, this whole is made up of 1, 2, 3, 4 1/4 pieces, and they are each known as unit fractions. So if I were to take, so this is one whole, if I were to color in 3 of these squares, we could show that this is equal to 3/4 by adding or multiplying. So with adding, we would say 3/4 is equal to 1/4 plus 1/4 plus 1/4. To multiply that, we would say 3/4 is equal to 3 times 1/4. Now we are going to extend our knowledge of unit fractions, and instead of adding unit fractions that will add up to part or all of a whole, we are going to take that and we are going to extend it into fraction equivalents to fractions greater than 1, greater than a whole. You may remember this when we would have a tape diagram that might have been as such, and this might have been divided into fourths, and this was equal to 1. And let's say we have 1/4. Again, the whole is 1, 2, 3, 4. So we have 1/4, 2/4, 3/4 plus another fourths. This would equal 5/4, which is larger than a whole because a whole is 1, 2, 3, 4. 4/4 equals the whole. So we could show this by saying 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, which equals 5/4, or we could say 5/4 equals 5 times 1/4. Well, there are other ways to show this as well. We could have said 2/4 plus 3/4 equals 5/4. As you can see, we have an improper fraction. The numerator is larger than the denominator. So we can make that a mixed number. We know that 4 goes into 5 once. There's at least one whole. The whole is 4 parts. And then we have 1 left over, so that's 1 1/4. We're going to take this a step further, and now I'm going to shift gears into thirds. And I'm going to say 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus one more third. Now you can easily add that. We know that we are dealing in thirds, so the denominator will be thirds, and then if we add all the ones, we have 1, 2, 3, 4, 5, 6, 7. So this would be 7/3. Well, one thing that I want you to think about is, if you look at this, 1/3 plus 1/3 plus 1/3 is 3/3, or 1 whole. So I can do that over here. This is 3/3, or 1 whole. And actually, instead of saying or, I'm going to put an equal sign, because that is what 3/3 equals. It equals 1 whole. And then we have our other little lonesome third here. And then we would add this. This is like saying 1 plus 1. So we have the 1 from here, we have the 1 from here, and then we have the third, plus 1/3 equals 2 wholes and 1/3, or like we have up there, or 7/4. thirds. However, you know Mr. Myers and I, and really no one in the math community, wants you to leave an improper fraction. We want you to turn it into a mixed number, and a mixed number is just the whole number and a proper fraction. So you can do this the way that I've shown you here. You can also do this with a number line, which I'm going to show you next. Before I show you the next step, I also want to add in one other part to this. So we have 1 plus 1 plus 1/3. We could also say, algebraically speaking, that this is like saying 2 times 3/3, or 1 whole, plus 1/3, which equals 7/3, or you can say 2 1/3. Another way you can show this problem is by using a number line. So you would draw your number line. Don't forget your arrows, because a number line goes on and on forever and ever both ways. And then we're going to have a 0, 1, 2, 3. And then we're going to divide these each into thirds. Okay, so there's 1, 2, 3/3 make 1 whole, 3/3 make another whole, and 3/3 make another whole. So we can show the same problem that we did before by doing this. 3/3, right, plus 3/3 plus 1/3. And again, you will get 1, 2 wholes, and 1/3. So that's just another way of doing the math like this. Okay. And yet another way we can do this on a number line is you draw the same number line, and we can actually do this, which is 6/3. Let me erase this out of here real quick. 6/3 plus 1/3. And we still come out with the same answer, 7/3, or 2 wholes and 1/3, 2 1/3. I will show you yet one last way to work this 7/3 or 2 1/3 problem using a number bond. So we can say 7/3, or remember it's 2 1/3, equals, we can choose, we can say 4/3 plus 3/3. You could have in here, one of the other options is 5/3 plus 2/3, and obviously you can say 1/3 and 6/3, 3/3 and 4/3, but just to remember, you can take that in to a number bond as well. So this problem, we started here, which is what we did a lot before the mid-module assessment, and we moved it over into a number line and then a number bond. You can do the same thing for subtraction, which I'm going to show next. So continuing on with the lesson, I can use a tape diagram to add or subtract fractions. So I'm going to do this model that we've been doing, and I'm going to divide this into thirds, but then each third is going to be divided into thirds. So this is 1 whole. This is 1 whole. And here we have 1 tiny third, right? So that is the same as 7/3 or 2 1/3. Now let's say we want to subtract. We have 7/3, okay? And I am going to just label this. This is 1, this is 1, this is 1/3. And let's say we have 7/3 minus 4/3. Now we know that since we have the same denominator and the 7 is larger than 4, we could just simply say, oh, well, that's easy, that's 3/3 or 1 whole. But visually, if you look at this tape diagram, and you see that this is 2 wholes and 1/3, and which is also 7/3, and we want to take away 4, we can cross out 1, 2, 3, 4, and we have 3/3 left, or of course 1 whole. Okay? Now I'm going to use another problem, but this time I'm going to use a number bond. And the problem that I'm going to use is 4 4/5. We know that 4 4/5 is made up of 4 wholes and 4/5, correct? Now, what we could say, we could make a fact family to go along with this, and we could say 4 4/5 equals 4 plus 4/5. It also equals 4/5 plus 4. Then we can say we can say 4 4/5 minus 4/5 equals 4. 4 4/5 minus 4 equals 4/5. And if you notice something, this is just a fact family. We have the whole number, and we have a part and a part. Part total. Again, part total. And then here we have we have the total part. So we have what we started with, what we subtracted, what we have left. And so in each of these, there are only 3 numbers. The only 3 numbers we use in this fact family is 4 4/5, 4 4/5. So when you're thinking about subtracting fractions, you can think of them as a fact family, much like we have done multiplication fact families. 2 times 3 is 6, 3 times 2 is 6, 6 divided by 2 is 3, 6 divided by 3 is 2. It's just taking the knowledge that you already have and transferring it over into something else, such as fractions. So if we're going to be using number lines as another method of subtracting fractions, I want to show you 2 more problems. The first problem is we're going to start here with 4, and this is 5, and then we're going to divide this into fourths. So here we have 4 1/4, 4 2/4, 4 3/4, and then 5, 4/4, which equals 5. Okay? So if we said 5 minus 1/4, we could do this. We can look at the number line and we can jump back 1. And we're going to say we're going to subtract 1/4. Well, if I subtract 1/4 from 5, that's still going to leave me with 4 and 1 2 3/4. We can use the number line to do another problem such as this one. I'm going to start with 6 here, put 7 here, I'm going to try to divide this into 5 equal pieces. So we have 1, 2, 3, 4, 5. Okay, so this problem is showing 6 holes and it goes to 7 holes, but in between we have fifths. So the whole is a fifth. So this would be 6 and 1/5, 6 and 2/5, 6 and 3/5, 6 and 4/5, 6 and 5/5, or 7. So let's say I wanted to say 7 minus 3/5. So I'm going to go back. I'm going to take away 1/5. I'm going to take away another fifth. And I'm going to take away the 3/5. If I take 3/5 away, as it says, that will leave me with 6 and 1/2 left. So now you're going to have an assignment, and your assignment is Lesson 22 problem set. I will make sure you get this as a link, but I'm going to do problems 1A and 2A so that you can understand what we are asking you to do. So you will take a screenshot of the picture, and there are actually 2 sides to this page. So you can see it goes all the way through 4F. So what you'll do is you will go in and you will click on Edit, and then once you're in Edit, you want to click the 3 dots, which are right here, and you want to click on Markup. So now once you're in Markup, you can make the picture large so that you can write on it. So the number 1 says draw a tape diagram to match each number sentence, then complete the number sentence. So I'm going to enlarge number 1 so that I have a nice space to write on. And it's 3 plus 1/3. Now I know that most of you, if not all of you, could just say, oh, 3 and 1/3, that's just 3/3. But we still want you to draw, that was a horrible line, still want you to draw a tape diagram to show this. So we have, I'm going to put this into thirds, and then I'm going to add just one more little piece over here. And I am going to say that this is 3 and then each one would be divided into thirds. I'm just making little dotted lines. And then this one here is just 1/3. So this shows us that this would show us that you understand that one whole, let me change the color here, that 1 whole plus 1 whole plus 1 whole equals the 3 plus your other third. And then your answer would be 3 and 1/3. So that would be for the first problem. Now you can see that I have written down here on letter C. Don't let that bother you. I just drew kind of large. If you need to use scratch paper, that's fine. Let's go on to number 2. Again, I'm going to go to Markup. Use the following 3 numbers to write 2 subtraction and 2 addition problems. So this is addition number sentences. So this is just fact families. Okay, so what we would do is you would start with 6 and 3/8 equals 6 plus 3/8. 6 and 3/8 equals 3/8 plus 6. 6 and 3/8 minus 3/8 equals 6, 6 and 3/8 minus 6 equals 3/8. So that is how you would do 2a and 2b. 3 is solve using a number bond. Draw a number line to represent each number sentence. The first one has been done for you. So they give you an example right here on number 3 of how you need to do this. So we have a number bond and we also have a number line. So I'm done with that one. I'm going to go over here to, this is C and D of 3, same thing. And then number 4, I will do the first one for you. So it says complete the subtraction sentences using number bonds. So you would go, I'm going to make this larger. And I'm going to say, I know that I have 3 holes. 3 holes. Whoa. I want to bring this over to point. 3 holes and 1/10. I'm going to break this up into the number bond. So the 3 is my top number. I'm going to break that up into 2. And then 10/10, because that equals another hole. So 3 minus 1/10, I know that I would have 2 left over plus 9/10 because I would take 1/10 from this 10/10, from this hole. So that would leave me with 9/10. So remember, what you want to do here is you want to take your hole right here and you want to take 1 hole away and keep, so take one away from the 3, which leaves us with 2, and then take that hole you borrowed and make a hole in fractional form, 10/10. So then your answer has to have the 2 as your whole number, and then whatever you would have left, 10/10 minus 1/10, which is 9/10. So this is going to be your assignment. You will be expected to complete the rest of side 1, so 1B, C, and D, and then 2B, and then 3B, 3C, and 3D, and then 4B through F. And also don't forget, if you have any questions, just come back to the video.